As the world approaches the era of non-humans, water challenges and their repercussions become more evident in different regions. Thus, we chose Mexico City, rich in Aztec culture and tradition, a civilization that expanded its lands on water, which allowed it to enhance the nutrients for crops, generating aquatic transportation routes, and supplying the city with a clean water source. The city's predecessor is Tenochtitlan, a city built on water. After Spanish conquest, the city was drained and rebuilt in a European style. The mismatch between the urban planning and the city's exponential growth led to severe water issues in Mexico City. During the urbanization process, the terrain became smoother and water eventually disappeared. While the artificial elements on site increased, natural species gradually decreased. With these increasing water issues, we're introducing local techniques originating from the Aztecs. These floating islands were made by layering mud, sediment, and vegetation on woven tree trunks in freshwater lakes and wetlands. This system is highly sustainable by using natural sediment for soil and plants to filter water during irrigation. We summarize the benefits of chinampas into four main aspects. Firstly, chinampas are an agricultural system with high productivity for various crops. The formation of chinampas begins as a floating land. The silt from the bottom of the wetland and plants' roots will stabilize the structure. They also serve for land expansion. This expanded land also provides habitation both for human and non-human species. Most importantly, it benefits the surrounding wetland. It has the capacity to bring back water to the center of Mexico City as well as improve the existing wetland water quality. Since it is a water-based system, there is a strong correlation between water degradation and chinampa reduction. We're speculating possibilities on different scales to revive chinampas in modern Mexico and achieve numerous benefits. Several units form a community-scale system with canals. There is potential for high efficiency in water management and water cycles. In terms of functions, chinampas could be divided into four layers. From bottom to top, the collection layer gathers waste, the delivery layer filters nutrients, the convention layer transmits nutrients to the crops, and the final top layer serves as habitation. Introducing chinampas into an urban system requires the original functional layers to convert into urban functions, like community or habitation, water filter, transportation systems, and water collection. The subdivisions of each urban layer allows us to implement different methods based on the urban elements. Before design, we focused on analyzing the water issues and their causes. Firstly, it is related to the topography and geographic locations. A high-altitude valley surrounded by mountains makes it easy for rainfall to accumulate within the city. During urbanization, lakes and rivers were drained almost completely. These changing water patterns caused flooding and water scarcity recurrence, which a current urban infrastructure cannot efficiently deal with. Excessive groundwater extraction has caused yearly ground sinkings. This subsidence further compromises the effectiveness of the drainage system, increasing the risk of flooding. We examine water-related environmental hazards, including flooding risks, water scarcity, site conditions, changes in land use, and land subsidence caused by our exploitation of groundwater. These water issues are our project's primary focus, inspiring us to propose innovative design strategies derived from traditional solutions in a modern context. By overlaying mapping data, we strategically selected two sites with the highest concentration of water challenges: Xochimilco, where traditional chinampas still function within the wetland, and a historic center where water resource integration is critically needed. The intervention on a city scale will start from 2 points, and after it expands over the years, it has the potential to intertwine and influence the whole city, bringing back this resource. We designed a morphology catalog that will serve as a base for our proposal, introducing variation in the shape and density to adapt to different activities. Inspired by chinampas, we propose a new system consisting of layers. The substrate is the primary element, over which several biomaterials like roots, moss, and mycelium will grow and expand the system's benefits. The composition and proportion of biomaterials will vary depending to the proposed functions. Echoing the concept, we transform the city's elements into layers. The first site is Xochimilco, a large wetland area with traditional chinampas. The context comprises wetlands, residential blocks, protected natural areas, and farmlands. By introducing our system derived from morphology studies, we emphasize water collection, storage, drainage, delivery, and filtration functions. Our selected starting point for our intervention is an area with elevated urban density and substantial farming activities. We're filtering the site's water resources to minimize the effects of pollution. In our proposal, we're reincorporating water into the city, thus reviving part of the ecosystem and reintroducing the local biodiversity lost during urbanization. We are using AI to visualize how the design can integrate into the current context. The 4 primary functions are distributed at different points and cooperate as a whole system. Besides the previously mentioned benefits, such as filtration and flooding control, the urban chinampas also improve the condition of land subsidence and biodiversity loss. As mentioned before, each functional unit will have its unique composition and cooperate on a macro scale. The historic center is in high contrast with Xochimilco. Water is mostly underground and highly polluted. For the historic center, we analyzed the essential urban layers, including transportation systems, city blocks, high-rise buildings, and open spaces. The parks and plazas will be the starting point for our design, since they have the potential to be the gathering areas for new water sources. Here, we will concentrate on water and redirect the analyzed water currents, recovering the essence of the city from Aztec times. The workflow of the following steps is similar to the one of the natural site. We simulate the expansion of the urban chinampas by introducing functional modules to revive water and biodiversity. The 4 main functional units will address the issue of water scarcity. Our design will enhance the city's capacity to collect and store water through intricate morphologies and the integration of biomechanisms. The tree's roots will stabilize the substrate and improve the land sinking faced by the city and guide the water into our focused area to store it underground. Our interpretation of the Chinampa system incorporates biomaterials such as root systems, mycelium, moss, and clay to create a circular system that enhances food production, water management, and environmental resilience. This project is designed as a prototype with the potential to be adapted into cities facing similar environmental challenges in Mexico and globally.